Driving. I want to share with you something that's really new. Just now I talked about how, in fact, we can drive by sensing, by planning, and then by acting. Where are you? What's around you? Figuring out what path to take. It's a mathematical problem. It's a path planning problem. And then lastly, take the action of driving. Well, we've been working for some time in creating an alternative approach to doing that. A little bit like what Brett, the robot, was doing. It learned by itself using deep learning and to figure out what actions it has to take. It didn't detect bottles. It didn't detect caps. It didn't detect bricks. It wasn't taught to do that. It simply taught, what is it that I have to detect? What action do I have to take? Basically, an end-to-end approach to training networks. We've been working on a project that's really, really super fun. The name of the car is BB-8. We have 3 cars. You're going to see BB-8 today, and you know BB-8 has friends, R2-D2 and C-3PO. And the name of the network is a brand new network that we created called DaveNet. This network is very different than the network that you just saw. The other network was detecting objects. This network is simply going to drive. And it's so cute. You're going to see BB-8 learn how to drive. And today we'd like to share with you our progress on developing the first self-driving end-to-end network we call DaveNet. Ladies and gentlemen, let's take a look at this.
Oh, holy cow. Whoa. Whoops. Wrong way. Ooh.
Ladies and gentlemen, DaveNet. Now, you guys, just very quickly, you saw what happened. DaveNet was actually figuring out where to drive when there were no lanes. It made a transition from asphalt to dirt. It was driving in the rain. It was taking curves all by itself. We didn't mathematically figure out how it should turn. It was just simply turning all by itself. After training by us, watching us drive, and all of the conditions by which we detected and the actions that we took, DaveNet now takes something very similar to that. And as we continue to train this network, I believe DaveNet will become superhuman in its driving capabilities. Well, if we want to push the limits of driving, we need to have the right platforms, the right computing platform to do the research. As you know, every computer scientist needs a computing platform, and our scientists needs a platform as well. And one of the things that would be really cool is to have, well, if you have a supercomputer, you really ought to have a supercar. And this supercar is the world's first autonomous race car. The first autonomous race car. It's designed by a great designer named Daniel Simon. It's 2,200 pounds, so it's, as you know, an F1 is about 1,500 pounds without gas. And it's going to be, well, I don't, we'll see how it turns out, how fast it is, but as you know, an electric motor has incredibly fast, high torque. It should be blazing fast. And so this is going to be the world's first autonomous race car. And along with that, if you have a bunch of people who get together to have an autonomous race car, you should have an autonomous race. The world's first autonomous race called Roborace. 10 teams, 20 identical cars. Every single car has to have exactly the same brain. And the thing that's going to differentiate it is our network. This is going to be differentiated by the creativity of computer scientists as we figure out how to train these cars to go at incredible speeds. This is going to be part of the Formula E season. Ladies and gentlemen, Roborace. Now that is a great looking computer, huh guys? Okay, that's it. Ladies and gentlemen, GTC 2016, I'm so excited about the work that we're doing together. The buzz is in the air, the air is electric, the environment here, the researchers, all the amazing work that you guys are going to do. We announced 5 things today. We talked about VR, we talked about AI, we talked about self-driving cars. We announced 5 things. The NVIDIA SDK, the essential tools for GPU developers. iRay VR, the first rendering capability for photorealistic VR. For designers, for architects, unbelievable tool. Tesla P100, the most advanced GPU ever made. The world's first GPU designed for high-performance computing centers, hyperscale centers. NVIDIA DGX1, a deep learning supercomputer in a box. The most advanced computer ever created, the highest performance single node, 170 teraflops, 250 servers in a box for $129,000. And then lastly, in autonomous cars, HD mapping, and then of course, really, really cool stuff, AI driving. Thank you guys. Have a great GTC 2016.